Alright, so in our last video, we saw how to simplify a matrix, and we used some methods to do that. And what this really is called, and what those things that we did are called elementary row operations. And there's 3 elementary row operations, and I'll go ahead and just list these out. So we have replacement. And replacement is kind of the granddaddy of them all. And that's where you replace, go figure, one row by the sum of itself and a multiple of another row. And that was, let's say we did 3 times row 1. Again, that is into row 2. That's what we're talking about when we mean replacement. Now our second elementary row operation is interchange. And we didn't get to this one in the last video, but all this really means is you're just swapping the place of 2 rows. So say we have our matrix. Move this over here just a little bit, give myself some space. Say we have 1, 3, 7, 2, 4, 2, and 8, 9, 1. Alright? And we want to interchange. So what we're going to do, the interchange merely just does this. I'll use a little different. So we're going to say interchange. And we get this. We'll say interchange row 1 and row 2. So we're just going to switch their orders in our matrix. This one's really straightforward. Alright. And then finally, our third one is scaling. In scaling, we're just going to multiply one row by a scalar. And I told you this is really useful when you're trying to get a 1. So, and what we did in the last video is we did 1/2 times row 2. And that kind of brought everything down for us a little bit, and that made it nice and neat to work with. So those are our 3 elementary row operations. One little piece of vocab that we're going to go ahead and learn right now is what is called row equivalent. Alright, so 2 matrices are row equivalent if one matrix can be made into the other using our elementary row operations. Alright, and the important thing about row equivalency is if you get something, you get 2 matrices that are row equivalent, alright? 2 matrices they share the same solution set. Now this just isn't one solution. Alright, this is the entire set of solutions. This is all the solutions. Now, that can technically be no solution. It could technically be one solution, and it can also be infinitely many. Alright, so that's the important thing about row equivalency. And then in the next video, we'll go ahead and kind of dive in a little more formally with what we were doing in previous videos.